Welcome. In this session, we will examine the financial metric that matters most in AI infrastructure, performance per dollar. We will look beyond sticker price to understand how network efficiency and utilization drive the true return on investment. Making AI infrastructure decisions, the sticker price of a switch or server is misleading. The true metric is performance per dollar, which we calculate based on the speed of job completion time relative to the total investment. For instance, high-performance systems like the NVIDIA GB200 NVL72 are designed to maximize revenue generation, specifically token revenue for LLMs, offering up to a 15x return on investment. In an AI factory, if your network slows down the compute, you aren't just losing time, you are actively devaluing your massive capital expenditure on GPUs. Therefore, infrastructure must be viewed as a holistic engine where efficiency equals currency. This flowchart traces the path of your investment. Starting with capital investment, the critical variable is infrastructure efficiency. If the network provides low latency and high bandwidth, you achieve fast job completion, leading to high token revenue and excellent performance per dollar. Conversely, network congestion leads to slow job completion. This results in wasted GPU cycles, expensive hardware sitting idle, which ultimately drives down your performance per dollar metric. Biggest enemy of performance per dollar is the idle tax. Because AI is a distributed computing problem, hundreds of GPUs must synchronize constantly. If the network introduces tail latency, meaning the last packet arrives late due to congestion, the entire cluster waits, forcing expensive GPUs to sit idle. In multi-tenant environments, noisy neighbors can consume bandwidth and victimize your critical jobs, further degrading performance. Standard lossy networks that drop packets force retransmissions, creating delays that directly reduce the effective value of your compute infrastructure. To maximize value, we must eliminate these idle periods. This sequence diagram illustrates the idle tax. Initially, the GPU cluster is computing efficiently. However, during data transfer, the network experiences congestion or a drop. This forces a delay or retransmission. Notice the block labeled idle wait time. During this phase, the cost meter continues to run. You are burning OpEx and electricity without generating value. Only after the network recovers does compute resume, highlighting how network quality directly dictates financial efficiency. Fix the idle resource problem, we focus on effective bandwidth. While standard Ethernet might claim high speeds, its effective throughput often drops due to collisions. Specialized platforms like NVIDIA Spectrum-X for Ethernet or Quantum InfiniBand utilize adaptive routing to dynamically steer traffic around congestion, ensuring up to 95% effective bandwidth utilization. Also employ advanced congestion control to prevent buffer overflows before they happen. By enforcing performance isolation, these technologies ensure that every dollar spent on networking translates into actual data movement, securing the ROI of the entire AI cluster. This chart compares rated speed versus effective bandwidth. Standard Ethernet network might only deliver 60% effective throughput for AI workloads due to collisions and unmanaged congestion. In contrast, an AI-optimized network like Spectrum-X achieves 95% utilization. That 35% gap represents recovered performance per dollar. You get nearly all the bandwidth you paid for, ensuring your GPUs remain fed and productive. Finally, performance per dollar extends to operations, OpEx. It's not just about buying hardware, it's about keeping it running. Platforms like NVIDIA UFM and NetQ drastically reduce troubleshooting time by pinpointing issues like what just happened in real time. We can also lower CapEx using NVIDIA Air to create digital twin simulating networks to validate changes without buying expensive lab gear. Furthermore, active tools like UFM Cyber AI detect failing cables before they kill a job. By automating deployment with tools like Ansible and NView, we reduce time to production, meaning your infrastructure starts generating value sooner. This state diagram maps the life cycle of cost-efficient operations. We start at design, then move to validate virtual using NVIDIA Air, saving capital on physical labs, then deploy automatically using Ansible for speed. Once running, we monitor with NetQ and UFM to keep OpEx low. Finally, we optimize using Cyber AI to prevent failures. This cycle ensures that every stage contributes to maximum ROI and high performance per dollar.